All right, in this second example, we're going to find the volume of the solid generated by revolving the region bounded by the curve x equals the natural log of y, the y-axis, and the lines y equals 2 and y equals 7 around the y-axis. So the first thing I'll do is draw a quick little sketch of my region. Here we've got x equals the natural log of y. Got our y-axis, and the lines y equals 2 and y equals 7. And so the region that we're going to be revolving around the y-axis is this one right here. Now, since we're revolving around the y-axis in this example, we want our slice to be perpendicular to the y-axis instead of the x-axis like we did in the first example. So I'm going to draw in my typical slice. It looks like this. And if I looked at what that slice looks like when I take it out of the solid, what we have is we have the center, which is the y-axis, which is x equals 0. And then the radius runs over here to this side of the solid, and that's at x equals the natural log of y. And so the distance from here to here is the natural log of y. So that's going to be the radius for our solid. And again, we're going to use that formula, pi r squared h, for the volume of one of the slices that comes out of this solid. And in this case, the thickness, since we're going with respect to the y-axis, the thickness is going to be dy instead of dx. And so we're just going to go ahead and set up our integral. We're going from y equals 2 to y equals 7. So we'll bring the pi out in front, have the integral from 2 to 7 of the radius, which is natural log of y, quantity squared, respect to y. And now we can just go ahead and either integrate this by hand, which is a tough integrate for us, so we're just going to go ahead and do this with our calculator. And so I'll pull up my handy dandy calculator, and we're going to have pi times the numerical integral of natural log, and I can just use x as my variable in my calculator. That doesn't matter one bit. And so we're going to integrate that from 2 to 7, and we'll punch this up, and that gives us the volume of our solid. And I lost my calculator there for a second. There we go. And I lost it again. And just comedy of errors. 34.793 is going to be our final volume for this solid. All right.